Okay, today we're going to be looking at conditional probability. So the word conditional here tells us that the probability is dependent on some additional information. Given about whatever the outcome or event is going to be. So what does that mean? So let's consider an example. Your friend randomly selects a letter from the word ace. So the probability they select the letter E is going to be 1 in 3. However, now let's consider we are told she selects a vowel. So the probability that she selects E, given she selects a vowel, is now going to be, so there's 2 vowels, so it's going to be 1 and 2. Now, we wouldn't write given that whatever the condition is. We use the symbol of just a line to denote that the given that. So given that is denoted by that. So when you see a line in the associated with probability of A given that B, we know this is going to mean the probability that A occurs given that B occurs. So that line tells us that this is conditional probability. Let's do some examples to see this. A child is selected at random from a group of 11 boys and 9 girls, and one of the girls is called Rose. Find the probability that Rose is selected given that a girl is selected. So the probability of Rose given a girl is selected. So how many girls are there? There's 9 girls, and she's one of them, so it must be 1 in 9. So because we've been told that it's a girl, we don't need to think about how many boys there are. We just consider how many girls there are, and so the probability is 1 in 9. So let's do another question. So this time we've got a table with the number of students in a class who study biology which will be denote with a big B, and chemistry, which we will denote by a C. So here's our table. This is the ones that study biology, and these are the ones that don't study biology. And we have our totals here. Here's our ones that study chemistry and don't study chemistry. And totals again. So we have 9 students who study both chemistry and biology, 8 who study chemistry but not biology, and that gives us 17 in total. There are 7 who don't study chemistry but do study biology, and 1 who study neither. And that gives us a total of 8, and then we add these totals up, 16, 9 and 25. So there's 25 students altogether. So firstly we want to represent the data as a Venn diagram. So we've got our complete set here, and this is going to be the 25 students altogether. Now we've got our biologists, and we have our chemists, and we know that there's one student who studies neither, so he'll sit out here. Now, how many study both biology and both chemistry? Well, that's our 9. How many study biology but not chemistry? So we've got biology and not chemistry, that's 7. And who study chemistry but not biology, that's 8. Now, we're going to use our Venn diagram to find, firstly, the probability that somebody studies chemistry given that they study biology. So the probability they study chemistry, given that, so conditional probability sign, they study biology. So they study biology and they study chemistry. So there's 9 students that study both chemistry and biology, and 16 students study chemistry altogether. So that's our total, and out of those 16, 9 of them study biology. Then secondly, the probability they don't study biology, given that they do not study chemistry. So the probability they don't study biology and don't study chemistry. So how many do not study chemistry? So you've got the 1 person out here and the 7 here that are just biologists. So that's in total 8. A number that don't study either is 1. Let's do one more example. 2 children are selected at random from a group of 5 boys and 7 girls. Find the probability the second child is a boy, given that the first child is firstly a boy, and B, secondly, the first child is a girl. So the probability the second one is a boy, given that the first is a boy. So there are total number of children is 5 add 7, which is 12. But when we come to the second selection, we're going to have one less. One's already been picked, so we're going to have 11 children. Now, if the first child was a boy, that means there's only going to be 4 boys left over. So the probability of the second being a boy must be 4 out of 11. So that's the answer to A. And B, the probability that the second is a boy, given the first was a girl. So again, we've had one child picked already. So there's only 11 children to pick from. But this time, because the first was a girl, we've still got 5 boys to pick out of. So the probability will be 5 out of 11. So I hope that helps.